Now, when it's come to subtraction of the modulus, we have seen how to make a table of addition of modulus. So now we have to look at how to make a subtraction table of a modulus. And subtraction, in addition, we used to go clockwise, then we count. But in subtraction, we used to go anti-clockwise for subtraction. So now here we say 0 minus 0. The pointer is here at 0. So we say 0 will remain here as 0. And 0 minus 1, that is we have to count 1 anti-clockwise. 0, 1, here we have 4. Then 0 minus 2, we have to count 2 anti-clockwise. 1, 2. Here we have 3. 0 minus 3, then we have to count 3. 1, 2, 3. Here we have 2. Then 0 minus 4, we have to count 4. 1, 2, 3, 4. Here we have 1. Then 1, the pointer is now going to be on 1. Then 1 minus 0 is to remain here. That is, we have 1. Then 1 minus 1, that is, we have to count 1 anti-clockwise. Here we said 1, which is 0. Then 1 minus 2, we have to count 2 anti-clockwise. 1, 2. Here we have 4. And we have to count 1 minus 3, that is, we have to count 3 anti-clockwise. 1, 2, 3. Here we have 3. Then 1 minus 4, we have to count 4 anti-clockwise. 1, 2, 3, 4. Here we have 2. Then also here we have 2 minus 0. So here we say the pointer now is at 2. 2 minus 0 is to remain here, that is 2. Then 2 minus 1, that is we have to count 1 anti-clockwise. Here we have 1. Then 2 minus 2, we have to count 2 anti-clockwise. 1, 2, which is 0. Then here 2 minus 3, we have to count 3 anti-clockwise. 1, 2, 3. Here we have 4. Then 2 minus 4, we have to count 4. 1, 2, 3, 4, which is 3. Then also here we have 3 minus 0. The 3 will remain here. That is, here we have 3. Then 3 minus 1, we have to count 1 anti-clockwise, which is 2. Then 3 minus 2, we say 1, 2, which is 1. Then 3 minus 3, we have to count 3 anti-clockwise. 1, 2, 3. Here we have 4. Then 3 minus 4, we have to count 4 anti-clockwise. That is, we have 1, 2, 3. Sorry. Here we say it. Let's take it from the beginning. 3 minus 0 is 3. 3 minus 1, that is, here we have 2. Then 3 minus 3 is going to be 0 because we have to count 3. 1, 2, 3. So here is 0. Then here we have 4. Then 3 minus 4, we have to count 4. 1, 2, 3, 4. That is 3 minus 4. So here we have 3 minus 3 is 0. Sorry. 3 minus 2, 1, 2. Here is 1. 1, 2. Then 3 minus 3, we have 0. Then 3 minus 4, 1, 2, 3, 4. Here we have 4. Then lastly, 4 minus 0, we have the pointer is going to be here at here. 4 minus 0, here we have 4. Then 4 minus 1, we have to count 1 anti-clockwise, which is 3. 4 minus 2, we have to count 2. 1, 2. Like this. Then 4 minus 3, we have to count 3. 1, 2, 3. Here we have 1. Then 4 minus 4, 1, 2, 3, 4. Here we have 0. This is how to get the table of multiplication. And also there are some questions that used to follow under subtraction or addition. Let's take for example now. When we say 3 minus 2, what is going to be 3 minus 2? We now have to look at the 3 is now refers to be the row. That is, this, the first number will refer as row, while this one will refer as column. So now we to check third row. This is 3, then under a column 2. Then we trace here. Here we have 1. So now 3 minus 1, 3 minus 2, we have 1. Then we say not 5. And also when we have another example, where we said 3, let's say 4 minus 3, or let's say 4 minus 1. Here we have what? This is the row number 4. This is the row number 4 under column 1. This is column 1. We have 3 mod 5. This is how to get a problem under a word, under a subtraction table. So whatever percent comes under mod 5, this is how to take the steps. The first number is referred as the row, while the second number is referred as the column. So take the row of 3 and column of 2, then you get this one. And also we have an example that they say find the sum of 4, 3 and 2 in mod 6. 4, 3, 2 in mod 6. Now what we're going to do, we now to find the sum of all these numbers. Here we say 4 plus 3, then plus 2. All here we have 9. So 9 under mod 6, how many times does 6 go into 9? We now to say 9 equals to 6 times 1. Or we say 1 times 6, any one, then plus what? What's going to be the remainder here? We say 3. So now automatically here we have 3 mod 6. This is how to take a problem under modules. Now when we take a multiplication, after we have seen how to make an addition table and how to answer the question under it, and we have seen the subtraction and also how to answer the question under it. So also here we have a multiplication. So this multiplication table, we have here, you are to write a multiplication sign. Then here we know the possible residues of mod 5 is 0 to 4. The possible residues of mod 5 is 0 to 4. So now here we say 0 times 0, here we have 0. 0 times 1 is 0, 0 times 2, 0, 0 times 3, we have 0, 0 times 4, here we have 1 times 0 is 0, 1 times 1, we have 1, 1 times 2, here we have 2, 1 times 3, here we have 3, and 1 times 4, here we have 4. Then we come to 2, 2 times 0, here we have 0, 2 times 1, here we have 2, then 2 times 2, here we have 4, then 2 times 3 is 6. So now 6, 5 into 6, 1 remainder 1, so we have to write the remainder here. Then 2 times 4, we have 8, 5 into 8, it goes 1 remainder 3. So here we have to write 3. So now here we say 3 times 0, here we have 0, then 3 times 1, here we have 3, 3 times 2, 6. 5 into 6, 1 remainder 1, so we have to write the remainder here. Then 3 times 3, we have 9, 5 into 9, 1 remainder 4, so here we write 4. Then 3 times 4, here we have 12. 5 into 12 is now goes 2 times remainder 2, so here we write 2. Then 4 times 0 here is 0, 4 times 1 here we have 4, 4 times 2 here we have 8, 5 into 8, we have 1 remainder 3, so here we write 3. Then 4 times 3, here we have 12, 5 into 12, it goes 2 times remainder 2, so here we write 2. Then here we have 4 times 4, which is 16. 5 into 16, it goes 3 times remainder 1. So this is the table of multiplication. And there are some questions that used to follow under a multiplication, like example now. When we say 3 times 4 under mod 5 is what? 3 times 4 mod 5. As I told you, this is mean row, while this is mean column. So you now have to check from the table. Row 3, that is here, and under column 4, so you have to trace. Column 4, here we have 2. So 3 times 4 is equals to 2 with a mod 5. And also when we have example, that is, let's say 2 times 3. 2 times 3, we now have to look at the second row, that is of 2. Then on the third column, 2, it goes here. Then this is the third column where we have 1. So here we say 1 mod 5. This is how to take a multiplication and a problem. Now division of a modulus. So in a division, we used to make a reference with multiplication table. When it comes to division, is almost the same, because that is why addition and subtraction, they are going hand in hand. Also multiplication and division, they are going hand in hand. So now when it comes to division, no need of you to plot another table. You are now to use a table of multiplication. How comes? Look at example now. We say it like here when we said example 3 divided by 4 under mod 5. 3 divided by 4 under mod 5. What are we going to do? We now to take it as a solution. Sorry, here we said 4 divided by 3 divided by 4, let's say it equals to x. We need to know what's going to be 3 divided by 4 under mod 5. We say it tends to be x. So now in this case, we can now say 3 all over 4, that is the division, is equals to x. So when we have this, we now to cross multiply and we say 4x equals to 3. So now, after you get this equation, what is the number in a multiplication table that when you multiply with 4 is going to give you 3? So you now to look at the 4 under row number 4. What is the number that if you multiply with column of this is going to give you 3? Then now you have to trace the line. Here is 3. It now gives us 3. So what is the number that we multiply? So it's 2. So now the value of x here we can now say it is equals to 2. The value of x is 2. So now here we say 3 divided by 4 is equals to 2 mod 5. Another example here we have, or we say it 2 divided by 3. Let's say it's equals to 2 divided by 3 mod 5. 2 divided by 3 equals to, let's say, as y. So also in this case, we now to say 2 over 3 is equals to y. So when we cross multiply, here we have 3y equals to 2. What is the number that when you take a multiplication table that is on row number 3 that multiply with another number to give us 2? So you now come to row number 3. This is row number 3. Then you have to check where do we have 2. So we have 2 here at the end. And what is the number that multiply by 3 to give us 2? Here we have 4. So now the value of y here we say is equals to 4. So now 2 divided by 3 is equals to 4 mod 5. So now this is how to take a division of a modulus. And after all this, what I want you to know in a modulus is that modulus is very, very important. Like today, if you can call it today's date, like here we are in 2018. So now 1st January of 2018, it happens to be on Monday. So now what is going to be the 1st January of 2019? In every common year, we have 365 days. 365 days is what makes a complete year. So now, with these 365, when you take a week, that is, when you say 365 divided by 7, or you say 7 times 52. 7 times 52 is going to give you 364. Then we say plus 1. 7 times 52 plus what? Plus 1, it will give us these days. So what we are talking about is only the remainder that we are looking for. So like today, maybe if 1st January of 2018, it happens to be on Monday. So 1st January of 2019, it happens to be plus 1, that it is going to be on Tuesday. And when we have like 2020, it is a leap year. So instead of you to add 365 days in a common year, but in a leap year the days are 366 days. So now, instead of you to add 1 on a leap year, you are to add 2 because it's a leap year. So now, 1st January 2018 is on Monday. 1st January 2019 is happens to be on Tuesday. So now 1st January 2020 you are to add 2 is going to be on Thursday. That is, you are to add 2 days. This is with the help of a modulus. You can be able to detect this and you can be able to know exactly how a calendar is. That is about a modulus.